Picture this. 3 astronauts board the Soyuz TMA-16M spacecraft. The air inside the capsule is thick with tension and anticipation. The mission they are about to embark on is a milestone in the history of space exploration. Scott Kelly, an American astronaut, and Mikhail Kornienko, a Russian cosmonaut, are about to spend almost an entire year on the International Space Station, ISS. But this isn't just any mission. It's a true test of human endurance in space. From this moment on, their bodies will be subjected to unprecedented scrutiny. Over these 365 days, the ISS will become a floating laboratory where more than 400 scientific experiments will be conducted. And the most fascinating part? The bodies of Kelly and Kornienko will be key elements in some of these studies. Have you ever imagined getting your blood drawn in a zero-gravity environment? Or undergoing ultrasounds while floating? They will even receive the first space vaccine. But what's the goal of all this? Essentially, it's to understand how the human body reacts and adapts to an environment as extreme as space, especially on long-duration missions. Now let me tell you something intriguing. Scott Kelly, in addition to participating in these experiments, is central to a unique study. And why is that? Because he has an identical twin brother, Mark Kelly, who is also an astronaut. Sounds like something out of a movie, right? While Scott spends a year in space, Mark will continue his life on Earth as usual. This difference in environments between the two brothers allows for a one-of-a-kind comparison. How will their bodies, which share the same DNA, react to such drastically different conditions? What insights will this give us about the effects of space on the human body? 2 big questions guide this research. The first, which is extremely relevant, concerns the feasibility of a manned mission to Mars. 1 year in space is nearly the time it would take for a round trip to the red planet. So, understanding how Scott Kelly adapts physically and mentally to space during this period could give us a clear vision of what we need to develop to make a mission to Mars truly possible. What else needs to be done to ensure that our astronauts are safe and healthy during such a long and challenging journey? And the second question, which almost sounds like science fiction, is this. Can astronauts really go blind in space? Have you ever thought about that? Many astronauts have reported vision problems after spending months on the ISS. And the scariest part is that this damage doesn't go away when they return to Earth. Scott Kelly, for example, has already been affected by this vision loss. Studying what happens to his eyes over the course of this year in space could be crucial to understanding and perhaps preventing this issue. So now I ask you, what really happens to the human body after a year in space? The journey to the ISS is quick, but intense. In just a few hours, the astronauts leave Earth and arrive at their new home in space. But the first 8 minutes of this trip are pure adrenaline. A dramatic launch, with the spacecraft accelerating to unimaginable speeds, breaking through the atmosphere and entering the vacuum of space. And when they finally dock with the ISS, the mission truly begins. But with it come the challenges. The absence of gravity brings a series of physiological effects that can be, to say the least, uncomfortable. Did you know that many astronauts suffer from space motion sickness? That's right. Zero gravity messes with our sense of balance. The fluid in the inner ear, which usually helps us maintain equilibrium, floats freely in space, which can create a sensation of disorientation. And when what your body feels doesn't match what your eyes are seeing, the result is nausea like you wouldn't believe. And it doesn't stop there. In the first few days in space, without the constant pressure of gravity on their spines, astronauts literally grow a few inches. Sounds amazing, right? But the back pain that accompanies this growth can be quite uncomfortable. Oh, and there's more. In just 24 hours, an astronaut can urinate between 1.5 and 2 liters of water, a result of the redistribution of fluids in the body. This is part of the body's adaptation to the lack of gravity, and believe me, the sensation of constantly being swollen with a face full of blood and skinny bird-like legs, is more common than you might think. That's why this phenomenon even has funny names: moon face and bird legs syndrome. After a week of nausea, excessive urination, and back pain, the astronauts begin to adapt. But this is when the long-term effects of space start to show. The astronauts' bones and muscles begin to weaken. Without Earth's gravity, bones don't need to support the body's weight, and as a result, they start to lose density. If nothing is done, an astronaut can lose between 1% and 2% of their bone mass per month. Now, imagine what this would mean on a round trip to Mars, where an astronaut could lose up to half the strength of their bones. And the worst part? This loss is irreversible. But don't think that astronauts are left helpless. They follow a strict exercise routine, dedicating 2 hours a day, 6 days a week, to minimize these losses. And the exercise machines specifically developed for space have been a major breakthrough in space exploration. Thanks to these machines and the astronauts' discipline, much of the bone and muscle loss can be mitigated. Of course, the ideal scenario would be the creation of artificial gravity, but we're still far from that. And even with all these efforts, the body still suffers. In space, the body tends to switch out endurance muscle fibers for explosive ones, meaning muscles lose some of their endurance capabilities. And what about appetite? In space, astronauts consume, on average, 30% less food than they need. This isn't because there's a shortage of food, but because they simply feel less hungry. And this loss of appetite isn't fully understood yet. One theory is that food tastes different in space. Without gravity, the warm air that carries aromas doesn't reach the nose as intensely, affecting taste perception. Plus, constipation, which seems to be common among astronauts, might also play a significant role in this lack of appetite. The type of bacteria in astronauts' digestive systems also changes in space, and we still don't know if this is a cause or a consequence. Now let's talk about DNA. The study comparing Scott Kelly with his brother Mark has uncovered some incredible findings. During his year in space, Scott's DNA wasn't altered, but the way it was expressed certainly was. Some parts of Scott's DNA that remained inactive in Mark became active during his stay on the ISS. This means that the proteins and chemicals produced by Scott's body were different from those of his twin brother on Earth. These changes could give us clues about how the body adapts to the space environment. And what about telomeres? Have you heard of them? They're like the little tips on the ends of our chromosomes' shoelaces, and they usually shorten as we age. But during the time Scott spent in space, his telomeres actually lengthened. Does this mean that space can make you younger? Well, not exactly. This lengthening was reversed shortly after Scott returned to Earth. Still, this discovery raises fascinating questions about aging and health in extreme environments. Now, what worries scientists the most is radiation. In space, without the full protection of Earth's magnetic field, Scott Kelly was exposed to much higher levels of radiation than his brother Mark. It's estimated that he received the equivalent of 10 X-rays a day. And what does this do to the body? Radiation can damage DNA, increasing the risk of cancer. This is one of the biggest challenges we'll face on long-duration missions, such as a trip to Mars. And the heart, how does it handle the lack of gravity? On Earth, the heart has to pump blood against gravity, especially to the legs. In space, without this resistance, blood tends to accumulate in the upper part of the body, causing what astronauts call moon face syndrome. This blood buildup increases pressure in the skull, which can damage the retina and lead to vision loss. And this is one of the main concerns for future missions to Mars. Now, let me tell you something new. A recent study published in Nature has brought to light a worrying discovery. During their time in space, astronauts' kidneys might suffer irreversible damage. It was already known that the risk of kidney stones increased in space due to the excess calcium released by the bones. But this new study suggests that the lack of gravity can cause structural damage to the kidneys, leading to a loss of renal function. Just imagine. If we don't find a solution, astronauts traveling to Mars might need dialysis on their way back. After a year in space, Scott Kelly returned to Earth, but the return was far from easy. His muscles and bones were weakened, his vision was compromised, and his body was in a state of elevated inflammation. Scott spent weeks feeling like he had a severe flu, struggling to recover. And all of this brings us to a crucial question. If this mission had been a trip to Mars, the journey there would have been just the beginning. How would it be to face all these challenges? With high levels of inflammation, bone, muscle, and vision loss, and radiation damage upon arriving on Mars? And how can we ensure that astronauts are fit to carry out their mission when they get there? The truth is, we still have a long way to go before we're ready to send humans to Mars. But each challenge we face in space teaches us something new about the human body. And the solutions we develop to help astronauts can also be applied here on Earth, improving the lives of people who face similar problems, like the elderly or those who are bedridden for long periods. Space is more than just the future of human exploration. It's an opportunity to advance technology and health, both off and on our planet. And after knowing all this, I have to ask, would you have the courage to spend a year in space? What do you think of the challenges and discoveries this could bring? Drop your thoughts in the comments. I'd love to hear your opinion. Thanks for watching, and see you next time.